applications, advanced technological advancement and innovation. So I've asked you from your past experience of working with electrical circuits, Ohm's law, power law, reading schematics, to come up with a possible product or design a device in which will prevent cars from not stopping at stop signs. Because that's the major issue today with drivers. There's many accidents with pedestrians as well as automobiles because people are not coming to a complete stop. So think of a device, and remember, I'm also asking you to come up with some possible electronic or electrical components that might be used, or some of theories, or some of the laws that might be applied in your design circuit, as well as what are some of the safety aspects when installing this device at a stop sign. Okay? So as groups, can you collaborate, work as teams, because that's very important in the real world, that you can work with each other and come up with those ideas. Okay? Any questions? So can you work together as a team and start figuring out what your design might be?
Oh, I have a question.
Yes.
Does that have to be something completely new, or?
It's entirely up to you, okay, on this. If you feel that there's a way to make sure that the automobile will stop at the stop sign, because that's the problem, okay, then you come up with your idea. Questions? Okay, so can you guys start brainstorming now as a group? Okay. Okay, Zach, Alexis. So what might be some ideas that you might be thinking of? Okay, and try to discuss this among each other.
When it's red, when it's like red, or at a stop sign. Or whenever there's a person on the road. Not that one. Post that shooting when it's red light or at a stop sign.
First of all, do you agree that it is a problem that people are not coming to a stop sign? Okay, so
I almost got hit a few times because I was in the crosswalk.
exactly.
It was a red light too.
So maybe if we could prevent, drivers from not stopping, maybe we would have less accidents and pedestrians wouldn't get hurt. So, good. Keep working.
It's a different type of thing.
Like, not 30 seconds though, but like a little bit shorter. So
Yeah.
Like it's please stop for like maybe 2 seconds. Just stop for like 2 seconds at least, and then go. I think if you're waiting 30 seconds,
Oh,
it's really.
I'm just coming up with the idea. I don't know. You guys can set the timer.
Do you think it would benefit if drivers came to a stop at a stop sign?
It would, yeah.
Yeah. Have you seen drivers just,
I've
Go.
almost
Yeah.
been hit.
even red lights, yeah?
Yeah. Well, I saw
So-
it yesterday.
Okay,
Yeah, I was
so,
almost hit.
if you guys can actually think of this and come up with a product, you think you might be able to,
See it.
no, you think you might even be able to manufacture and sell this product? Do you think people would use it?
Oh wait, this product that we have idea right now.
Yeah.
Oh no.
No, but is it possible
Oh,
if you
it's-
came up with a design that you could actually manufacture it and sell it to maybe to the city and county?
Yes.
Okay, so it's a real problem. Come up with a good idea.
Guess the little post shooting.
And what are some of your ideas?
Or camera that's in front of the car.
This pre-existing thing where it's like if it sees a car and you're like parking, it'll automatically stop you. Put that in the front. If it sees pedestrians, automatically will stop you.
Okay, so now having that idea, what might be some of the components that you'll be using. Okay?
I think when we do the pressure plate though, if you like.
So once you come up with your product or design, think about what are some of the components that might be used in the circuit. Okay?
Oh wait.
No, like
there
13
was
feet away.
something
No,
about-
that's so high. No, like the pressure plate, like the distance between the pressure plate and the stop sign. Because if the pressure plate is right on the stop sign, it starts to go right through it. So the pressure plate has to be before, so as to hit it, the thing starts to come up.
Yeah.
So what might be some of the components you might have to use?
A lot of wires. A lot of wires.
Wires, what else?
Gears, resistors.
Okay. What are some of the other components you've used? Okay.
Like a repelling magnet. Two lines opposed, so then with red light, so do things.
Okay.
Unblock
Brainstorm.
stuff, and then it shoots. When it's green light, it shoots back down.
They should put like a light on the stop sign, so like when they hit the pad, everything lights up, so they know it's coming up.
Can one of the person in your group record your device, your component, and some of the safety that you consider in installing this device? Because I would like you to share your ideas with the whole class. Yes. Oh, yes, that's pretty good. We can take care of that tomorrow, okay? Okay. I know, but we focus on the test. Yeah? Okay? So, what else would you use for designing this device? What are you using right now in front of you?
Camera.
Right in front of you.
Oh.
What kind of components have you using or might you need? Huh?
I feel stupid.
No. What are you touching and showed me?
Steering.
Huh?
Oh wait.
Yeah, what is that called?
Faster.
What is the whole thing called?
Circuit board.
Oh.
Okay.
Oh, you mad.
A printed circuit board. Good. Very good.
I was talking about the big car.
No. But you naming components that you use. So from what you've worked in this class, okay, try to utilize that experience that you've already gained. Try to relate what we've done in the class up to now to these problems that you are working on. Okay? The more you can relate to what you've learned, will identify if you have an understanding of the standards that we're trying to target in this class.
Should we see if it stays up? Like what you said. The phone. So you can stop. You know, like, if you're tired already, you have to stop. I think if it's clear, we can go.
Michael, one idea of a safety that you might utilize in installing this device at the stop sign. What one of the safety factor might you use? Appropriate clothing. Okay.
Gear and stuff. You don't want a helmet, because if it's like concrete, putting it down.
But in construction, you always have a helmet, so that's a good idea. Anything that will prevent injuries, okay?
It's mostly red, right? It's just mostly about
fuse up there, but they'll go down past it.
Do you folks have your idea?
Yeah.
Okay. Have you already determined what possible components you might be using in this device? Okay. Very good. So where are we now?
Like component.
Okay, component. Okay. What type of components have you used for your breadboard? Do you feel that that will be part of a circuit? Yeah, good. Okay. So basically, what you've learned in the class, you're applying it now. Okay.
Once you raise it up and once you bring it down, right on the line. So they actually have to
No, you stop. Yeah. So I would say like when you're turning right, it will stay up for 2 seconds.
Should be long enough.
negative comfort traffic.
Yeah.
Okay.
No, like if there's traffic, the head's gonna stay up
Hello.
or stay down.
So what's the main point of the time that they have to stop?
Make sure that they stop.
Yeah. The bottom line is they stop.
Yeah.
Yeah.
What's gonna malfunction?
And if they don't stop, then they'll just damage their car.
So you're saying that if they don't stop, the car will be damaged.
Well, I mean, if they don't slow down, then they might get like a little bump, or maybe worse.
Oh, that's a big incentive to stop, yeah.
Yeah. You stop the car, or you pay for it.
Very good.
We got stuck.
On what?
So we was thinking pressure plate, but then we didn't think of traffic. So once, like if there's traffic and cars are still on the pressure plate, wouldn't it just stay up or stay down?
But that's where you have to decide.
Problem solved.
Does your pressure plate? What about your pressure plate?
They'll say if you go one stop, they'll damage their car.
In other words, is there only one type of pressure plate? Do you know how pressure plate actually work? But you should research that and have a better understanding about pressure plates, because how do they actually work? Sure.
You have to turn it off and on.
Zach, in today's technology, electrical technology, is it possible to create pressure plates that can pretty much detect whether or not it's the same car or different car? You think so? Okay. No, but how is the technology in electronics, how has it evolved over a period of time that make you say, yes, that can be done?
So not like they have a chance to respond and
can it know that it's a different car?
Mister, type of pressure plate.
Wait, can a pressure plate have like a camera on it too? Or it's just
Real life.
So my question to you is this, okay? Say you're a pressure plate. How would you know if it's a different car?
on a week?
Think about that. What do you know about the car? What's the fundamental about the car that touches the pressure plate? Okay, tires. Okay, most vehicles have how many tires that will touch the pressure plate?
At one time?
Yeah,
Would be like two.
two at a time. Which will be which two is first? Front and then?
Back?
So, would you know if it's a different car?
Yes, I would.
Very good. Okay.
Going through it to power it.
Oh, so like, it's like after the first car.
Yes, yes.
Yeah, and then come back again to the column. Yeah, I see what you mean. Should I just put it?
So, if you were now an electrical engineer, do you understand how to design device for real world problems? Yeah. So if you could design this device and manufacture this device, what's your chance of being successful in the industry? If you can solve real world problems, what's your chances of being successful?
Oh, chance. Pretty good.
Pretty good, yeah. Yeah. It's really, so your job as the electrical engineer is to what?
Solve real world problems.
Exactly. Perfect. Perfect. Yes. Okay, so how about maybe another couple more minutes and let's begin to share our ideas among the groups, okay? So you'll see other ideas, other perspective of devices that people think of that will make cars come to a complete stop at the stop sign. Also, what components and what safety also is involved.
The timer is just on the red light and red and the stoplight itself. Pedestrians. By the time you're on the posts go down, they should be like in the middle of the road or almost to the end of to the other side of the. Unless they're like really dumb.
Come on, let's collaborate and get the job done, gentlemen. So, how about suggesting safety work to get the task done, yeah?
it might detect motion from the car and then, wait, no, it'll stay down.
You know, what about when there's pedestrians crossing the on a crosswalk?
How about you contribute and write one of the safety things that we'll consider in installing the electrical device?
So like what, like we should like.
What are some of the things that we do in the class, in other words, as far as safety?
There's like a timer that goes off, and after a certain amount of time, the pillar is raised.
When you solder, what is one of the safety rules that you follow?
Safety glasses.
Okay. Should they wear safety glasses whenever they're working on the field?
Yeah, and have some.
Okay.
So like every car is stopped and pedestrian cross safely. And then after the.
Oh, you could outside the thing, but if it comes to
How are you guys doing?
talking about a stop sign or stop sign.
Stop sign.
Or,
It could work for both too.
Was stop light a circle that you don't?
okay. If you're not too sure, then move on to the next question.
Oh, what's the next question?
Safety.
If there's like a
What safety guidelines or rules should be followed for installers, for electrical installers?
because you if it's but you also
Okay.
you know cars that need to turn and stuff.
What safety guidelines should we use when?
Yeah, so name one. Name one. Especially what we do in the classroom. Hmm? Shoes. Wear shoes. Appropriate attire. Correct. What else?
When you come working with stuff, always wear helmets,
Helmets.
which
Good.
also falls in safety attire.
Okay.
I guess the thing that you mentioned, if we're working with electricity, you mentioned something about with your hands, like don't hold something like that, or else it will run trees.
Okay, so use one hand on electrical circuits.
Right.
Yeah. Good. Then at least what we're learning in class is actually relevant here.
Are you, do you have anything in mind?
For the rules?
Yeah.
Yeah.
Rubber shoes. Rubber shoes. Not working on a lab.
What?
Not working on a lab.
Like, how much longer you guys need?
5 more.
5 more minutes. How much longer you folks need?
Maybe 5.
Okay. So how much longer you folks think you need for complete your assignment?
3 minutes.
3 minutes, okay. Anyway, 3 to 5 minutes and then let's share, okay?
So if something was bad, we need to plug into it and need to fix whatever is wrong or find out what's wrong. So something for malfunction.
Let's give it another video. You know how actually there's like training.
How long it goes from the pads, yeah, the pads including the elevator. So whoever has a pad, the elevator connected to that and going up to one of the poles or something. So we can get access to see what is wrong or if we can fix it just with the computer. If it's gonna need to be fixed by hand or it can be fixed by electronics.
Okay, start wrapping it up and then we can share out. Sharing is also helpful to also give you ideas on what others think.
I was gonna say switch from transmission to technical switch period.
Could you see yourself designing something that solve real world problems? Yeah. You should have a good grasp on components that you would use in a circuit. You notice every circuit you did in class utilize pretty much the general type of components that you used. If you open up a motherboard, what are you going to find?
Lights,
Yes.
transmitters, transistors.
Or similar, yeah. Okay, are we ready to share out? Okay, volunteers. Might as well go. Okay, can we all give our attention to group one?
You guys want to name? No. So our safety invention is called none shall pass. What our design will do is that when a car comes and hits a pressure pad, these pillars will start to raise at the stop line. So it'll force the car to come to a complete stop before they actually can move on to their next destination.
Okay,
And to have the pillar go down, stuff like that, there's a secondary pressure plate that will acknowledge that, they're there, they're stopped, and that will start to bring the pillar down, stuff like that. So it makes it a little bit more safer and stuff. And as my colleague here pointed out, that with just having one pressure plate, they could always bypass, if there was a timer and stuff like that, because they slow down, like immediately turn after the pillars are down.
good. Okay, how about your group?
They're basically the same thing, but it runs. It works not on the pressure plate, more like on the red stoplight itself. Whenever it's red, the posts are up for like a few seconds, then it goes back down.
Okay. Okay, and your group?
Ours is basically like, since there's already cameras that can detect maybe if a car is nearby, it will automatically stop itself. You can have the same thing for the front, where if it's detecting a pedestrian, as you get closer, it will automatically stop itself also. That's it.
So it's a computerized system in the car.
Essentially.
Okay. Okay. What kind of components might you find in this electrical device that you're creating? Wires?
Wires, resistors, transmitters.
Okay.
And lights, LEDs.
Yeah.
Okay. Anything to add to that?
Same thing.
Okay. How about your group? Anything to add?
Did you guys say switches or?
Yeah.
Oh, okay.
Or
The circuit board? No, I don't know about it.
The printed circuit board. Good. And what was the other one?
chips.
Very good. Integrated circuit chips, right? You find them almost in a lot of computerized systems today, microprocessors. Okay. How about safety? Always a good idea to be safe and to protect yourself and protect other properties, etc. So, what might be some of the safety considerations? And we'll go backwards this time. Okay. Your group. What are some of the safety features you might incorporate in installing this device?
like
Good.
no sleeve shirt and no deadly injury and stuff like that.
Okay, so no long sleeve, no jewelry. Okay, what else might you consider as an electrical installer?
Safety glasses,
Wear safety glasses,
possibly a hard hat,
hard hat,
closed shoes.
and shoes. Okay, so a lot on the safety attire. And your group?
Be very vigilant of your surroundings, and and basically make sure you know what you're doing, that you're not goofing around with your work area, you're not, rough housing and stuff. It's a job, so you want to get it done then and there.
Very good, very professional like in the job. And that's what you need to do, whenever you're working with electricity. And hopefully the habit that you are building in a classroom can transfer. Okay, so that's why we need to enforce safety in the classroom too. So we can take that same habit and take it to when we actually do have a job in the field. Okay, you guys did good. I appreciate you guys working together as a group. I think that is important. Collaboration, teamwork, and everybody was participating. That's very important, and it gives you an idea about things that we do in the classroom. How are we going to apply that? Okay, so like the components you learned. I mean, could you have said that at the beginning of class? Probably not, but and the safety components. So all of these things are kind of indicating to me that the standards that we're teaching for the course, you are transferring that and learning it. Very good. Okay, good job, class. Good job.